We mentioned that we want to use adjusted R squared as opposed to R squared. And the reason for that is that any variable that we want to add in a regression always adds to R squared. Because R squared is the explained variation, we can see that any variable that we want to add, for example, adds an additional contributed explained variation. So let me explain this further. When we got the ANOVA, so let me print this out, the ANOVA for each of the variables, we mentioned that these, for example, is the contribution by square footage to the explained variation. And then this is the additional contribution by house age. So the contribution that they can have is always positive. In other words, we can only add to the explained variation. So for that reason, the best strategy to get R squared increase is just to add more variables. But if we want to make sure that we can measure how good the model is, we want to adjust based on the number of predictors. In other words, penalize R squared if you add more predictors. So in that case, the adjusted R squared is a better metric because it can not only increase, it can decrease if the variable is not adding enough predictive power. So that's a good way to measure if the if the model is explaining well the variation on the response. So always when you have more than one predictor, you want to use the adjusted R squared.